Welcome to your daily dose of AI news. It's Monday, February 17th, 2025, and we're diving into the latest research papers from arcxcv.org. Ready for a whirlwind tour of advancements in AI, from making models more efficient to understanding the intricate thoughts of large language models.
It's amazing to see the sheer volume of research coming out. It seems like every day brings new discoveries pushing the boundaries of what AI can do.
Let's kick things off with the pursuit of more efficient AI models. One paper proposes using multi-fidelity simulation to train those computationally expensive models, like those complex climate models that require massive computing power. This new approach could be revolutionary.
Absolutely, this multi-fidelity approach leverages cheaper, lower-fidelity simulations to guide the training of the more complex high-fidelity model. It's like using a rough sketch to guide the creation of a detailed masterpiece, saving tons of time and resources. This could open doors in fields where simulations are essential but incredibly demanding.
Makes sense. Another paper tackles the efficiency of diffusion models. Those popular tools for generating realistic images and data, they can get bogged down by the sheer number of dimensions in the data they're trying to model. What's their solution?
They've developed what they call dimension-free score matching, a technique that estimates the score function of data distributions without being hampered by the number of dimensions. This leads to faster training and potentially even more realistic outputs from these models. Imagine the possibilities for creative tools generating photorealistic images or composing music with unprecedented nuance.
That's impressive. But efficiency isn't the only concern. Making AI models more trustworthy is also crucial. One paper introduces a method called Diamond to address this challenge.
Diamond helps us peer into the black box of AI models by pinpointing the crucial interactions between features. Knowing which features the AI relies on is key to building trust in its decisions. This is especially important in high-stakes applications like self-driving cars, where understanding the AI's reasoning is crucial for safety.
Right. But real-world data is rarely clean and perfect. How are researchers tackling the challenge of noisy data?
Well, one paper presents a new approach for likelihood-free inference that's robust to misspecification, meaning it can handle situations where the model doesn't perfectly match the real-world data, which is often the case. It's a powerful tool for dealing with the messiness of reality, ensuring AI models can perform reliably even with imperfect information.
So we're seeing advancements in making AI models more efficient, more transparent, and more robust to real-world data. What about fairness? Imbalanced datasets are a common problem that can lead to biased AI systems. How's this being addressed?
Researchers are tackling this head-on. One paper introduces a new theoretical framework for handling imbalanced datasets, proposing a class imbalanced margin loss function, proven to be more consistent and fair.
This loss function could help level the playing field, so to speak, especially when some classes of data are much more represented than others. Are there other tools to combat this bias?
Yes, along with the new loss function, they've developed learning algorithms called IMAX that work in conjunction with it. This combination could lead to more accurate and unbiased AI systems, particularly in areas like medical diagnosis or loan applications where imbalanced data sets are prevalent.
That's a big step towards ensuring AI systems are used ethically and responsibly. Speaking of trustworthiness, let's not forget about adversarial attacks, those deliberate attempts to fool AI models. What's being done about those?
Researchers are always developing defenses against these attacks. One team has created a fusion network designed to be resilient to such attacks. This architecture combines a U-net with a transformer-based defense mechanism, ensuring high-quality output even when the input data has been manipulated.
This type of defense is vital for security systems or medical imaging, where tampering with data could have serious consequences. Now let's shift gears and dive into the fascinating realm of large language models. These models have advanced incredibly fast, but understanding how they think remains a challenge.
One paper digs into the lines of thought in LLMs, suggesting that despite their vast complexity, these models might rely on simpler underlying mechanisms.
You mean these incredibly complex models might operate on more fundamental principles than we initially thought? That's pretty amazing.
It seems so. The research suggests that the complex thought processes in LLMs can be approximated by a stochastic equation with just a few parameters. This could be a game changer, offering new ways to understand and potentially control their behavior. Imagine being able to guide the reasoning process of an LLM, ensuring more accurate and reliable outputs.
Another paper explores a method called statistical coherence alignment to improve the thinking of LLMs. Tell me more about this.
Sure, this technique enhances representation learning in LLMs by applying coherence constraints during training. This essentially helps the model create better internal representations of language, leading to more stable and interpretable behavior. We might see LLMs that are less prone to generating nonsensical or contradictory text, moving closer to human-like language understanding.
These advancements in understanding LLMs are truly remarkable. Speaking of applications, let's explore how AI is being used in healthcare. One striking example is NeuroX Vocal, a system that analyzes speech to detect and explain potential Alzheimer's cases.
Imagine a future where a simple conversation could provide valuable insights into cognitive health. NeuroX Vocal could revolutionize Alzheimer's screening and diagnosis, making it easier and more accessible, which is crucial for early detection and intervention.
Early detection is so important for any disease, especially one as complex as Alzheimer's. Beyond diagnosis, AI is also being used to improve accuracy in other healthcare tasks.
Yes, one paper introduces aspect-oriented summarization, a technique that generates multiple summaries of a document, each focusing on a different aspect. Researchers use this to predict psychiatric readmissions with greater accuracy, demonstrating its potential for handling lengthy medical records and extracting crucial information for better decision-making.
Multiple summaries might seem redundant at first, but capturing different facets of a patient's history can paint a more complete picture, leading to more informed predictions. This is AI at its best, augmenting human capabilities in complex fields like healthcare.
Another team has developed a machine learning framework that visually represents how brain anatomy changes over time, called the lifespan tree of brain anatomy. This tool is being used to develop diagnostic tools for dementia and Parkinsonism, offering hope for earlier and more accurate diagnoses.
Seeing the progression of these diseases visually through this lifespan tree is a powerful concept. It really shows the potential of AI to not only analyze data, but also present it in a way that facilitates understanding and drives medical breakthroughs. AI's impact goes beyond healthcare, reaching fields like robotics and chemistry.
Absolutely. One paper introduces SELP, an LLM-based planner that generates safe and efficient task plans for robots while adhering to user-specified constraints. Imagine robots that can reliably follow complex instructions, making them even more valuable in a variety of domains.
From manufacturing and logistics to even assisting in surgery, the applications are truly vast. And on the chemistry front, researchers have created Mass Spec Gym, a benchmark dataset for developing machine learning models that can identify molecules from a mass spectrometry data.
This dataset is a significant step towards using AI to accelerate the discovery of new drugs and materials. Imagine AI helping us unlock the secrets of a molecular world, leading to breakthroughs in medicine, materials, science, and more.
The possibilities are seemingly endless. But before we get ahead of ourselves, let's pause here and take a moment to absorb all these incredible advancements.
It's really fascinating to see how AI is pushing the boundaries in such diverse fields. We're seeing a convergence of AI with other cutting-edge technologies like quantum computing.
That's a great point. One paper explores MQFL-FHE, a framework that combines the power of quantum computing with the security of homomorphic encryption for training AI models on sensitive data.
This framework could revolutionize healthcare. Imagine hospitals collaborating to train AI models on huge amounts of patient data without compromising individual privacy. This could lead to more powerful and personalized medical AI models, improving diagnoses and treatment strategies while protecting patient confidentiality.
It's amazing how seemingly different technologies can work together to solve real-world challenges. While quantum computing might seem like a distant future, researchers are actively working to make it happen.
Absolutely. Another paper tackles the challenge of training quantum machine learning models efficiently. They've developed Momentum QNG, an algorithm that uses Langevin dynamics to improve the training process.
Langevin dynamics simulates the movement of particles. How does this apply to quantum machine learning?
Well, by simulating these movements during training, Momentum QNG helps quantum machine learning models navigate the complex world of potential solutions more efficiently. It prevents them from getting stuck in suboptimal solutions, leading to faster convergence and better overall performance.
These advancements in quantum machine learning are really exciting. But let's not forget about the continuous innovation in more established areas of AI, like supervised learning.
You're right. One paper explores the use of small loss bounds for online learning with separated function classes. This approach utilizes Gaussian processings to develop algorithms that are more efficient and adaptable.
Could you explain small loss bounds and how Gaussian processes fit in?
Small loss bounds refer to algorithms that perform better when the data is well structured or easily separable. Gaussian processes are great for modeling uncertainty in machine learning. In this case, they help create algorithms that adapt to the specific characteristics of the data, making the learning process more efficient.
It's a reminder that even in well-established fields, there's always room for improvement and new ideas. Now let's focus on computer vision, a field where AI is making big strides.
A major issue in computer vision is the rise of deepfakes, those incredibly realistic AI-generated fake faces. A new paper offers a comprehensive review of both the creation and detection of deepfakes.
Deepfakes pose a serious threat. They can erode trust in media and even be used for harmful purposes. What insights does this paper provide?
It gives valuable overview of the latest deepfake technology covering both the technical side and the impact on society. Understanding how these manipulations are made and detected is key to fighting their misuse and protecting against misinformation.
Beyond the challenges, computer vision also offers exciting opportunities for healthcare. One paper looks at using CNNs and GANs for classifying ocular diseases.
Imagine a future where a simple eye scan could diagnose a range of eye diseases accurately. That's the goal of this research. They use GANs to create synthetic data, improving the performance of their CNN-based classification model. This could make eye care more accessible and affordable.
This could be a game changer, especially in areas with limited access to specialists. It's a great example of how AI can make healthcare more equitable.
Another research team has developed a framework for very precise interactive segmentation in images and videos, building on the Segment Anything model, or SAM.
Sam has already made a big impact in computer vision. What does this new framework add?
They've enhanced SAM with new modules that allow it to perceive fine details and maintain stable prompting capabilities. This results in highly accurate segmentation masks, even for complex scenes in both images and videos.
So this improved SAM can precisely isolate specific objects or areas within a scene, which has many potential applications.
Exactly. It has implications for everything from image editing and video analysis to medical imaging and robotics. Accurate segmentation is a fundamental component of many AI applications.
It's amazing how AI keeps pushing the limits of what's possible in computer vision, both in understanding and manipulating visual information. And it's not just about understanding and manipulating AI, it's also being used to enhance the quality of images and videos.
One paper explores noise-controlled CT super resolution using a conditional diffusion model. They're using AI to improve the resolution of CT scans, which is especially important in medical imaging, where high-resolution images are crucial for diagnosis and treatment planning.
This could lead to earlier detection of small abnormalities and more precise interventions. It's another example of AI's potential to transform healthcare. Are there other innovations in image enhancement?
Yes, another team has developed Deep Tree Tensor Networks, or DTTNs, a new architecture for image recognition. These networks, inspired by quantum physics, capture complex relationships within images, potentially leading to better performance on recognition tasks.
Tensor networks originated in quantum physics. How are they being used for image recognition?
DTTNs capture high-order multiplicative interactions across features. This means the model can understand complicated patterns and relationships within images that might be missed by traditional convolutional neural networks. It's a great example of how ideas from different fields can come together to create exciting advancements in AI.
AI's reach goes beyond image recognition. It's also being used to tackle real-world problems in environmental science.
Researchers have used machine learning to map the bathymetry of inland water bodies in Alaska using Landsat satellite data and a random forest regressor model. This data is essential for understanding ecological systems and managing water resources in a region facing the effects of climate change.
It's a fantastic example of how AI can be a powerful tool for environmental monitoring and conservation. And in medical image segmentation, a new method called QMax VIT UNet Plus has been developed for scribble-supervised segmentation.
Instead of needing detailed annotations, this method uses rough sketches to train the model, making the process of creating training data much faster and cheaper. It's a form of weakly supervised learning where AI models learn from less precise, more readily available data.
This could speed up the development of AI-powered tools for medical image analysis, making them more accessible to researchers and clinicians globally. Today, we've explored a vast amount of AI research, from fundamental advances in model efficiency and trustworthiness to groundbreaking applications in diverse fields.
The pace of innovation in AI is incredible, and we're just beginning to see what's possible.
Before we wrap up our deep dive, let's look at some more exciting developments in language models, robotics, and chemistry. Welcome back for the final part of our AI news journey. We'll wrap up with some cool developments in language models, robotics, and chemistry.
Sounds good. Let's start with multitask learning in language models. Researchers are looking at ways to make smaller language models more efficient multitask learners, challenging the dominance of those big, resource-intensive large language models.
Smaller models that can handle multiple tasks. Interesting. What approach are they using?
They're combining two powerful techniques: upside-down reinforcement learning and synthetic data distillation. They use a large language model like Llama 3 to generate synthetic training data, and then use that data to train a smaller GPT-2 model with upside-down reinforcement learning.
So they're basically transferring the knowledge from a large model to a smaller one, optimizing it for multiple tasks. What does this mean in practice?
This technique lets smaller models perform as well as state-of-the-art models like Llama 3 while using far fewer resources. This opens up a lot of possibilities for deploying multitask language models in places with limited resources like smartphones or even embedded systems.
That could be a game changer for things like chatbots, virtual assistants, and personalized education, making powerful AI more accessible. Speaking of chatbots and virtual assistants, another paper looks at the capabilities of GPT-4o's voice mode.
GPT-4o with voice capabilities is a big step forward. Researchers have been testing its ability to understand and process audio, trying it out on tasks like intent classification, spoken command classification, and even analyzing singing.
It sounds like GPT-4o is moving beyond text, understanding the nuances of speech and music. What are some of the key takeaways?
GPT-4o is great at understanding spoken commands and figuring out intent from speech. It's also surprisingly good at avoiding hallucinations, which is a common problem with large language models, but it still struggles with things like predicting audio duration and accurately classifying instruments.
Every technology has its strengths and weaknesses. It's exciting to see these multimodal language models evolving, moving us closer to a future where we can seamlessly interact with AI using both voice and text. Let's move on to a paper that focuses on adapting smaller, multilingual language models for low-resource languages.
You're right. A lot of languages don't have the huge amounts of data needed to train large language models effectively. This research explores adapting smaller models for these low-resource languages using both corpus-based and graph-based methods.
So they're using external knowledge sources like knowledge graphs to improve the performance of these smaller models. What's the impact of this approach?
It's a step towards making language technologies more inclusive. They found that even small adaptation datasets can significantly improve performance, especially for languages with limited training data. This paves the way for developing AI tools and services for a wider range of languages, bridging the digital divide and promoting linguistic diversity in AI.
For our last paper today, let's look at one that investigates combining post-training quantization with Q1RA for deploying large language models.
Quantization techniques reduce the memory and computational demands of models, making them easier to deploy on devices with limited resources. QORA is a low-rank adaptation technique that makes things even more efficient. This research explores whether combining these two approaches can lead to better overall performance.
So they're trying to make large language models more practical and accessible without compromising performance.
Exactly. Their findings show that this combined approach can outperform standard quantization methods and even come close to the performance of full parameter fine-tuning in some cases. This could make powerful language models available to everyone, allowing them to run efficiently on a wider range of devices, from smartphones to edge devices in the Internet of Things.
And that brings us to the end of our AI News Roundup for today, February 17th, 2025. We've covered an amazing array of advancements from making AI models more efficient and trustworthy to exploring their groundbreaking applications across many different fields.
The pace of innovation in AI is truly remarkable. We've seen significant progress in overcoming challenges and opening up new possibilities.
We hope this deep dive into the latest research has given you some valuable insights into the exciting developments shaping the future of AI. Until next time, keep exploring, keep learning, and stay curious about the ever-evolving world of artificial intelligence. 36E